Hello, welcome to College Algebra 4.4 notes for fourth block on September 23rd. Solving linear systems using matrices. So matrices are written as rows by columns. So you think of columns as you think of the White House. Columns are up and down, so columns are up and down on a matrix. So example 1, the rows, we have 3 rows by 2 columns, so 2 up and down. Letter B, you have 2 rows by 2 columns. Letter C, you have 3 rows by, so the by is with an X, 3 columns. And the last row, you have 1 row by 3 columns. M by N is how they're read. Augmented matrices, we're going to write matrices in this form today. So what you do is the augmented matrix looks like this. Look at letter A. So we just take, let me blow this up a little bit. You take the coefficients, 1, 3, negative 2, 1, and put them on the left side of this matrix, which is now a 2 by 3 matrix. And what's on the equal side goes there. And you draw a little line down the middle. So the dimensions of this augmented matrix are a 2 by 3. All right, so writing an augmented matrix for the first one here, you would have a 3, negative 5, 1, 1. I like to draw a dotted line here and then 7, 4. All right, letter B is 1, 1, negative 1. 2, there are no y's. Column C is 1. And then 2, negative 1, 4. And then your solutions, or the answers are here, 5, 3, and 0. And now on the next part here, we're going to go backwards. So this means I have a 1x plus a 4y equals negative 2. Second equation is 1x minus 1y equals 3. This one would be an x, no y's, equals 5. This is a y equals 1. Last one here is a 2x plus a 3y plus a 4z equals 6. Negative 1x, no y's, plus 5z equals negative 2. And x minus 2y plus 3z equals 1. Now we're going to use something called Gauss-Jordan elimination method to solve systems. What you need to know, we have these things called row operations, and these are the only things that you can apply to matrices in augmented form. You can interchange 2 rows, multiply every element in a row by a non-zero real number, and add a row to a multiple of another row. Kind of entertaining. All right, so example 1. When you see this notation, what that means is I'm flipping row 1 and row 3. So what happened was I have row 1 is 0, 0, 1, 0, 0, 3, 1, 1, 1, 1, 0, 0, 4. I'm going to flip those, so my new matrix is 1, 0, 0, 4. And then the 0, 0, 3, 1 goes to the so these two switch places. And then 0, 1, 7, 2, this down the middle. Letter B says I'm taking 1/3 of row 2 and it becomes row 2. So row 1 stays the same, 1, 0, 5. And then I'm taking 1/3 of row 2, which means divide those by 3. So 0 divided by 3 is 0, 3 divided by 3 is 1, negative 6 divided by 3 is negative 2. And then letter C, taking negative 2 times row 1, adding it to row 2, and it becomes row 2. So what that means is row 1 stays the same. Row 2 becomes this. So I take negative 2 times row 1. So negative 2 times 1 is negative 2, plus 2 gives me 0. Negative 2 times this 1 is negative 2, plus 3 is 1. And then negative 2 times 4 is negative 8, plus 6, negative 2. Next thing that we need to know today is, in the Gauss-Jordan elimination method, our goal is to use row operations to obtain an augmented matrix that has 1s on the diagonals and 0 everywhere else. So I need diagonals of 1, which means we'll end up with a solution of 1x equals A, 1y equals B. Try the first one. First thing you do is write it in this form. Goal 1 is that needs to be a 1. It is. So that needs to be, or first thing you have to do is make sure that's a 1. So step 1 must be 1. Step 2, make that number in this spot, make that number a 0. So we're going to do that by taking row 1 plus row 2. If I add those together, and then that becomes row 2. First row stays the same, 1, 2, 7. Add those two together, you get 0. Add those two together, 4. Add those two together, 12. Step 3, make that 4. Make this a 1. We're going to do that by dividing that by 4. So we're going to take row 2 divided by 4 becomes row 2. So leave the first row the same, 1, 2, 7, and then this becomes 0, 1, and 3. Last step, 4, make this number a 0. You're going to work with the row 2, so you're going to take negative 2 times row 2, add it to row 1, becomes row 1. This number is based on what that number is. It's the opposite of it every time. So second row stays the same. First row, so you take negative 2 times 0 is negative 2 plus, or 0 plus 1 is 1. This gives me negative 2 plus 2 is 0. And then 3 times negative 2 is negative 6 plus 7 is 1. So what that means is this number in this spot is x equals 1. And the number here is y equals 3. All right, so I'm going to finish the last two equations here, at least number 2. First thing you do is write it in a better marker. Write it in the augmented matrix form. And I can see that if I switch those two rows, then that the 1 is in the top spot, which I need it to be. So I'm going to say row 1 switch with row 2. So I have 1, negative 3, 14 in the top row, and then 2, 1, 0. Now I need to make this this 2 a 0. So I'm going to multiply row 1 by negative 2, add it to row 2, and it becomes row 2. This number here will always be the opposite of what's sitting there. And so then you also go to the opposite row too. All right, let's see what I end up with then. I get top row stays the same, 1, negative 3, 14. Bottom row becomes, so I have negative 2 times 1 is negative 2 plus 2, I get 0. Negative 2 times negative 3 is 6. 6 plus 1 is 7. And negative 14 times negative 2 is negative 28 plus 0, negative 28. Next goal, I need to make this 7 a 1. So I'm going to take row 2 divided by 7 becomes row 2. So first row stays the same. Bottom row becomes 0, 1, and -4. Next goal is to make this -3 a 0. So I'm going to take row 3, or row 2, 3 times row 2. So it's the opposite of -3, plus row 1 gives me row 1. So 0, 1, -4 is there. Then I take -3 times 0 is 0. 0 plus 1 is 1. Sorry, by 3. 1 times 3 is 3. 3 minus 3 is 0. 3 times -4 is -12 plus 14 is 2. Which means now I am done. I have a diagonal of 1, so x equals 2 and y equals -4. All right, example 3, last one of this top set here. Write it in matrix form, so 2, -1, 8, and 3, 2, -2. Goal 1, make that 2 a 1, so I'm going to take row 1 divided by 2 becomes row 1. So I get 1, -1/2, and 4. Second row stays this, 3, 2, -2. Now I need to make this 3 a 0, so I'm going to take -3 times row 1, add it to row 2 becomes row 2. So 1, -1/2, and 4. One times -3 is -3 plus 3, I get 0. All right, you need a calculator now. So you're taking -1/2, so -0.5 times -3, and then add 2 to that, and I get 3.5. 4 times -3 is -12, plus -2 is -14. Now I need to make that 3.5 a 1, so I'm going to take row 2 divided by 3.5 becomes row 2. So 1, -1/2, and 4 in the top row. Second row is 1, 1. So take -14 divided by 3.5 and you get -4. Now I need to make that -1/2 a 0. So I'm going to take 1/2 of row 2, add it to row 1, and it becomes row 1. So row 2 stays the same, 0, 1, -4. 0 times 1/2 is 0 plus 1 is 1. 1/2 times 1 is 1/2 plus -1/2 is 0. 1/2 times -4 is -2 plus 4 is 2. So that means x equals 2 and y equals -4. All right, I'm going to skip these 3's and I'm going to go to number 6. Choose a new color. Let's go with purple or darker blue. All right, so I have 3, 1, 1, 6, 2, 2. I need to make this 3 a 1, so take row 1 divided by 3 becomes row 1. So that gives me 1, 1/3, and 1/3. And leave the second row, 6, 2, 2. Now I need to take -6 times row 1, add row 2 to it, becomes row 2. So 1, 1/3, 1/3. -6 times 1 is -6 plus 6 is 0. 1/3 times -6 is -2 plus 2 is 0. This also gives me 0. I have a row of zeros, which means all real. Then you just write x, y such that one of those equations, 3x plus y equals 1. All right, last example, number 7. So this is going to be a 1, a -1, a 1, a -3, 3, 4. That's a 1, so I'm good there. So I need to make that -3 a 0. So I take 3 times row 1, add row 2 to it, becomes row 2. So 1, -1, and 1. So I take -3 times 1 is 3. 3 minus 3 is 0. 3 times -1 is Negative 3 plus 3 is 0. 3 times 1 is 3 plus 4 is 7. So I have 0 equals 7. So that is no solution.